Our goal here is simple. Give you the essential insights quickly so you can grasp what's happening with computation from the chips right up to, well, us.
Exactly. We're digging into the sources on some radical shifts, AI hardware, new software putting AI right in your OS, and maybe the most mind-bending part, new findings about the human brain itself, the thing AI is trying to emulate.
We're looking for the so what behind the headlines.
Right. What does it actually mean when machines act more like us? But we also find out how little we, still understand ourselves.
OK, let's unpack this. Pour cet épisode du podcast de Philippe, on fait le tour de 4 nouvelles dont 3 sur les IA. Vous en pensez quoi ensuite? On en parle sur le podcast de Philippe pour comprendre ce qui se passe en ce moment avec Notebook LM qui nous résume le tout comme d'habitude.
Good question.
Let's start at the foundation, the literal engine. New computing architecture coming out of China. Sources are detailing a massive breakthrough.
Yeah, this system called Darwin Monkey.
Darwin Monkey, also nicknamed Wukong, after the Monkey King. It's a neuromorphic computer. And the leap it represents is... it's kind of staggering.
It really is. And it helps to understand what neuromorphic computing actually is. It's about mimicking biological brains, right? This CNRS definition points to low energy, high efficiency, and more intelligence. It's different from traditional computers. It uses, get this, spiking neurons.
Spiking neurons. So
Yes.
like our brains transmit signals.
Yeah.
Electrical impulse.
Exactly like that. Instead of just processing ones and ifs constantly, they only fire when needed. Much more efficient.
Okay, and this is where the scale just blows my mind. Darwin Monkey from Zhejiang University's National Brain-Machine Intelligence Lab. It has over 2 billion spiking neurons.
2 billion?
And over 100 billion synapses. I mean, compare that. Intel's Hala Point was the previous biggest, right?
Yeah, Hala Point topped out at about 1.15 billion neurons. Roughly an owl's brain complexity.
An owl. But Darwin Monkey at over 2 billion neurons. That's approaching the scale of a macaque monkey's brain.
It is. We're talking about a significant jump in complexity, getting closer to modeling, higher order animal brains.
How did they even build this thing?
It uses 960 of these advanced Darwin 3 neuromorphic chips all networked together. But here's the truly crucial part, the detail that changes the game.
Okay.
Power consumption. The whole system, this near macaque scale brain, runs on just 2,000 watts.
2,000 watts. That's like a couple of powerful gaming computers. That can't be right.
It is. That low power draw is maybe the biggest deal here. It completely changes the economics of building powerful AI.
Right. It suggests AGI or steps towards it might not need these gigantic, power-hungry data centers forever.
Yeah.
You could potentially run very smart systems much more locally.
Absolutely. That efficiency opens a door wide for scalable AI edge computing. Because the neurons only fire when they have data, it's inherently event-driven and power-sipping compared to traditional chips.
So what can it do? What are the applications for this kind of power?
Well, it's a massive step towards artificial general intelligence, AGI. It enables faster, more accurate high-level tasks, logical reasoning, content generation, complex math problems, even autonomous learning. Think adaptive, flexible intelligence.
And it's not just for building AI, right? The sources mentioned simulation, too.
Yes, that's also critical. It's a platform for neuroscientists to model actual brains. They can simulate everything from zebrafish up to mice, potentially even elephants eventually.
So it helps us understand biology while building technology.
Precisely. It's a two-way street.
Okay, so that's the hardware frontier. Let's shift to software, what this means for us, like right now on our computers. OpenAI seems to be making big moves.
They are. They're not waiting around. This acquisition, they made the startup SAI and its app, Sky. It's designed specifically for macOS integration.
And this isn't just another chatbot helper, is it?
No, not at all. This signals OpenAI's push to embed AI deeply into the operating system itself. The key word is agentic.
Agentic AI. Explain that. What's the difference?
Okay, think of it like this. A chatbot is like an intern you email specific tasks to. Draft this email. Summarize this.
Right. Okay.
An agent, like Sky aims to be, is like having an assistant sitting beside you, watching your screen, understanding the context of what you're doing without you explicitly asking every single time.
So it sees what I'm doing and jumps in.
Potentially, yeah. If you're stuck on some code, it might recognize that context, offer a suggestion, maybe organize related files, or even draft documentation based on what it sees you doing, all through natural language understanding of your screen.
That sounds incredibly useful, but also a bit intrusive.
That's the tension, exactly.
And Sky was built by ex-Apple engineers, the ones behind Workflow, which became Shortcuts.
The very same. Art Weinstein and Conrad Kramer. They know macOS inside and out, how to build that deep integration. OpenAI's VP, Nick Turley, said they want ChatGPT to help you accomplish your tasks, not just answer questions. That's the agentic vision.
So this puts them head-to-head with Microsoft's Copilot features, Perplexity's Comet, others trying to be that AI layer on your computer.
Definitely. It's the next battleground. But you hit the nail on the head earlier. The privacy and security implications are huge.
For Sky to work, it has to see your screen, your apps, your data.
Everything. And given past scrutiny, like with their Atlas browser concept, OpenAI absolutely needs to be transparent about how that data is used and secured. User trust is paramount here.
Okay, hardware, software. Now let's pivot completely. Forget silicon for a moment. Let's talk about the original computer.
The human brain.
The ultimate hardware.
Our final source suggests our minds can actually bend time. How does that even work?
It sounds like science fiction, doesn't it? But we're talking about documented experiences of time dilation.
Time dilation, like in emergencies. Often, yes. People in accidents, extreme athletes, sometimes even people in deep meditation, report that seconds seem to stretch out, slow down. They feel like they have much more time to think and react.
There was a study mentioned by Steve Taylor.
Yes, he experienced it himself in an accident back in 2014, got fascinated, collected nearly 100 similar stories.
And what did his analysis find? Was it always triggered by danger?
Over half were linked to physical or emotional shocks, like falls, car crashes. But interestingly, others happened during intense concentration or altered states, not necessarily danger.
And the feeling during it, not panic.
That's the really striking part. Despite often terrifying circumstances, most described feeling incredibly calm and having this unusual mental clarity while time seemed slow.
So what's the scientific explanation? Why does this happen?
Well, the leading hypothesis has been about noradrenaline, the stress hormone. The idea is a massive release floods your system, speeding up your internal processing so much that the external world appears to slow down. An illusion created by your brain running faster.
Okay, that makes some sense for accidents.
Yeah.
But you said it happens in meditation too.
Exactly. And that's where the noradrenaline theory kind of falls short. You're not typically flooded with stress hormones while meditating calmly. So it doesn't explain everything.
The source material also seemed pretty firm against the memory illusion idea, right? The theory that you just remember more details later, making it seem like it lasted longer.
Very firm. Taylor found less than 3% of his participants felt it was just a trick of memory afterward. The overwhelming majority insisted they experienced the slowdown in real time. They were consciously aware of having extra moments during the event.
So if it's not just stress hormones, and it's not just how we remember it, what else could it be?
Taylor proposes it might be a genuine shift into an altered state of consciousness. He calls it changing your time world. It suggests our perception of time is far more flexible, more malleable than physics might suggest.
And this isn't just anecdotal. Athletes report it.
Commonly in high-level sports, yeah. The source mentioned a hockey player feeling an 8-second play took 10 minutes subjectively. It's also observed under certain substances like LSD. It points to our biological hardware having this latent ability we barely understand.
Okay, let's try and pull these threads together. We've covered a lot.
We have. From silicon brains mimicking monkeys to software agents watching our screens to our own minds potentially bending time.
Yeah, summarizing it, we saw the physical limits of computing pushed by neuromorphic tech, like Darwin Monkey, massive scale, incredible efficiency.
Then the practical limits of software challenged by agentic AI, like Sky, moving beyond simple answers to autonomous action on our devices.
And finally, the very limits of our own biological reality, questioned by these experiences of temporal distortion. How our own brains perceive time isn't fixed.
And it makes you think, doesn't it? We're building these incredibly complex AI systems like Darwin Monkey, trying desperately to replicate a macaque's brain on the path to AGI. Yet our own brain, the evolutionary cousin of that macaque brain, holds these profound secrets, like the ability to fundamentally alter its perception of reality, of time itself. It really poses the question.
Will AGI ever truly capture the full richness, the weirdness, the flexibility of human consciousness? Or is something like controlling subjective time uniquely human?
A provocative thought to leave you with.
This has been The Deep Dive.
You've got the key insights into where AI and even our own perception might be heading.
Help us to reach 2,000 subscribers and share our podcast, Le Podcast de Philippe.